Right. So, so far we've been plotting some graphs, and the point of the plotting the graphs is just for me to show you that um, when we end up drawing a line, that every set of coordinates on the line will match up with the equation of the line. So the simple one is y equals x. And as you can see, anywhere on the line, I mean, the crosses match the equation, but also anywhere that doesn't have a cross. You don't actually, you just join up the lines, but the points in between the crosses also match the equation. And that's the same for any equation of any line on any graph. We're looking at straight line graphs because they're a little bit easier than the other line graphs, but the same idea approach is follows. So if we now look at the equation for a straight line and try to understand it in terms of the graph that it ends up drawing, we'll notice a couple of things. And we can draw an equation for a line in various different formats, but what we always want to be trying to do is rearrange it to the format we see over here. So we have it's always y is equal to, so we're essentially working out what would the y coordinate be, and we're saying the y coordinate would be equal to some multiple of x of the x coordinate plus some number. So the amount of x's, in this case, you can see that is 3. So in the example below, we're saying that the y coordinate would be equal to 3 multiplied by the x coordinate, and then we're going to add 4 to it. So these gaps here can be given the general sort of symbols as m and c. C. So in this equation, we're saying that m is 3 and that c is 4. Okay, so we can see that the c is the number there. So as you can see, that's 4. And the m is our number of x's, and that's 3. Now, when we looked at a few graphs with some, we noticed that the C, I've used different colours here annoyingly, but never mind. In fact, I've used the exact opposite colours, but never mind. The C value is the y-intercept, or in other words, where the line intersects or crosses the y-axis, which is the vertical line. So that's an easy one. It's actually relatively easy to understand why as well, because when it crosses the x-axis, the y-axis, when it crosses the y-axis, we will notice that you can notice that the x coordinate would in fact be 0, because that point there, that vertical line, is where x is 0. So I use these lines, these dotted lines last lesson to kind of show you what I mean. So when everywhere on this vertical line right now, on this vertical dotted line, x is negative 6. And over here, x is negative 2. Over here, x is 3. But on here, which is the y-axis, x is 0. So at the y-axis, x is 0. And so in other words, when we're working out what the y value would be at the y-axis, which is when x is 0, y would be equal to m, in this case 3, but it could be anything, multiplied by 0 plus c. So you can see that this would disappear, and you just have y is equal to c. And that is why that's that the C value is where it crosses the y-axis. Okay. So so we can see that that's the y-intercept. What is the m value? What is the number of multiples of x? That is what we call the gradient. So at the simple, and it's labeled here. At a simple level, we can say that the gradient is how steep the line is. So if it has a high gradient, this line is steep. So let's imagine I'll draw a line. I don't want it to be dotted now, really, do I? And I'll make it a little bit thicker so we can see it more easily. So this is not a very steep line. This is a very steep line. Okay. So this one, a gradient like this would be very, very low. A gradient like this would be very, very high. So what about if the gradient was 0? Well, it wouldn't be any slope at all. It would be flat. So in other words, if it was y is equal to 0x plus c, y is always equal to, as this now we're talking about m equals 0, not x equals 0, then it would be a flat line at that point. So I'll make it a proper flat line now by holding on to shift. And a line graph that looks like that, for example, would be y is equal to -3. Or like that would be y is equal to 3. It's gone through the 3. And y is always 3 along that graph, no matter what x is. Likewise, you can have a vertical line, in fact. And this time it wouldn't have y in the equation. This would be different to what we've got here. It would be x is equal to something. And this is x is equal to -5. You can have a negative gradient. A negative gradient would be when the line goes down like that. Okay. And a negative steep gradient, a high negative gradient like -10 would be a steep line down, and a low negative gradient would be a gentle line down. But up is positive, down is negative. Okay, so let's look at it a little bit more about what specifically does this number mean, the gradient. We know that high is steep, low is not steep, gentle. The actual way to work it out is like this. You take any 2 points on the line, ideally quite far apart. So in this case, we've chosen the opposite end. So it's good to do it as far apart as possible, but also don't make your job too hard. Make it so it's easy to measure the things that we need to measure. And what we're going to do is we're going to draw a dotted line. It doesn't matter if we stop there. We could just draw it till the end of the line, end of the graph, like that, from one point horizontally. And oops, that's not quite what I wanted to do. Then draw a vertical line down from the top, and in either way you can see there's a triangle forming here. So then we write the change, we work out what the change in x is. So the x went from, as it went from here to here, it went from 0 to 3. And change, these little triangles, they basically mean change in. So triangle x means change in x. Okay, so this little triangle means change in. And you do the same thing with the y. So y went from 1 all the way up to 7, so the change in y is 6. So to work out the gradient, m, you do the change in y divided by the change in x would be 6 divided by 3, so 2. So, and we can see from this example that the intercept is 1. So we end up with the equation y is equal to 2x plus 1. Okay. One thing I didn't explain when we taught this last lesson is that you can also do the gradient just from the coordinates, so without actually drawing the line. But sometimes you might find drawing the line is easier. So this, let's just say this is point 1. So I'll just label it as 1, and the coordinates at point 1 is 0 and 1. And this is point 2. The coordinates at point 2 are 3 and 7. So we could say that the first number is the x. So x1, no, so the x coordinate of point 1 is 0, and y1 is 1. x2 would be 3, so the x coordinate of point 2, that's 3, and the y coordinate of point 2 is 7. So when we want to work out the change in x, we could just say it's x2 minus x1, which is 3, minus 0, which is 3. Okay, which we got already. And the y and the change in y is y2 minus y1. The good way of doing it this way is you can do it without a picture. You can do it without the graph. And another thing when you're doing it is to make sure that you don't lose track of which one's the second coordinates, which one's the first coordinate, because when I minus y2 from y1, I don't want to accidentally minus y1 from y. I don't want to minus them the other way around, because then I'll end up with my gradient will be the wrong sign, so that I might end up with the gradient as -2 instead of +2. So y2 is 7, y1 is 1, so it's going to be 7 minus 1, which is 6. And so I get the same, and then I just do the same thing as before. So that's a little recap of what we did. So we're just going to keep practicing this. I think we've completed that one there. So we're going to have a go at question 4.